Hello, and welcome to the Visibility for Evolving Networks webcast, brought to you by Gigamon. My name is Juliana, and I'll be your event moderator. Our presenters today are guest speaker Andre Kindness, Principal Analyst at Forrester Research, and Shazad Merchant, Chief Strategy Officer at Gigamon. Today, Andre will present It's More Than Spanning More Ports or Tapping More Links, and Shazad will cover Visibility for the Next Generation of IT. Just before I pass the presentation off to Andre and Shazad, I wanted to review a couple of logistical items about the webinar. The first thing is you'll notice a chat feature in the bottom left-hand side of your monitor. Please feel free to use this to post questions or comments. At the end of the presentation, we will hold a QA session in which I will read back your submitted questions to the presenters so they may answer them. Secondly, just to the right of that, you will notice a calendar module. This is for you to schedule a more in-depth and detailed phone conversation on your particular needs and interests. Please note that as a thank you for taking this next step, we're providing participants with a $25 gift card, which will be sent to you following the phone discussion. With that, let's get started with the program. Here's Andre Kindness.
Thank you very much, and it's a pleasure to be here. Appreciate everyone taking time out of their busy schedules to hear about Forrester-related research. And I'd like to thank Shazad for inviting me to co-host this with him, and the Gigamon team for putting this together. And to be honest, this is probably one of the most significant points in networking to really start to talk about some of the subjects coming at hand. I mean, a lot of the attention has been focused in on the data center itself and virtualization, but the reality is it's really small potatoes if you consider, what's going on with networking as a whole. And whether it's this particular research or client inquiry calls or Forrester's network assessments or our larger Forrester surveys, companies are really starting to approach the end of the road when it comes to their network and the way they've designed it. And what I mean by this is that, networking has historically been done in parts, a wireless or the LAN or the data center network. But the reality is with the fluidity of data and applications within data centers themselves or between data centers or even creating and moving in between these hybrid data centers that include clouds themselves, it's hard to really define the beginning and end of a network. And the other thing is, think about, let alone connecting mobile users to the location of those apps, whether it's in a data center or another data center or it's in the cloud itself. I mean, it's no longer this hub and spoke design system or this tree system that we've come to love within networking itself, but a mesh of virtual links, much like what you see above in the screen. Consequently, this means that we really need to think about optimizing this infrastructure and the user experience. And to be able to do that, we have to be able to monitor every aspect of it to make readjustments around what's going on within that, those virtual links, to be making sure that people are connected to the right resource. And so then monitoring itself can't be this, afterthought with most organizations out there. It can't be a, willy-nilly putting a tap out here or spanning a port off a switch, just because you might be having one particular issue. What I'd like to do over the next 15 minutes is take you through the future of networking and why organizations like yourselves will have to really think about your monitoring strategy and how that relates to your network and if you're thinking about SDN, and start to really realize that the intelligence of this network that you want to create is going to be predicated on the fact is how strong this visibility platform you have to do this. And you have to audit the tools and the taps and span ports that you have right now and figure out how to fill in the pieces and really optimize that infrastructure to be able to lay out where this infrastructure needs to go. And here's the kicker of it. It's not about networking, but the reality is that all that information in the network is going to want to be used by the application team. It's going to want to be used by the server or data center teams or even the business itself. And so, this investment is about selling it to everyone else because everyone else is going to want to have a piece of this investment, when we think about monitoring. Now, a lot of you probably know this story already, the Indian story about elephants and blind men. And as you know it, I don't want to dive into it, but I bring it up because the world I live in, most of the calls I get from clients who are trying to solve a problem or issue don't realize at the beginning of the call they have approached the problem like the blind man looking at an elephant or touching an elephant. As an analyst, and for Forrester, I cover the spectrum between layer 2 to layer 7 services. So, clients are calling about, routing and switching issues, or specifically what's, issues that are across their WAN, or issues they might be having with VMs in a data center and not being able to move from one spot to another because of what the issues are within the network itself, or the fact that they're having, poor wireless experience. And each one of those things, the reality is, in that call itself, we start to realize, and the questions I ask is, they're approaching it from a technology standpoint of looking for technology to solve the problem, when in many ways they haven't understood the problem itself, that it's more of a gut feeling to really understand what's happening with the network, because they haven't had the tools in there or put the monitoring capabilities to really figure out that the issue is within a particular part of the network. They're just guessing on it. And we spend a lot of time just dancing around and finding out that the visibility within the infrastructure today, I would say, is poor at least. And here's the kicker, though, that if we take a look at what's happening within a data center, and we talk about within the data itself, that moving VMs within a data center and being able to track them and making sure you have the quality of service and the bandwidth, minimum bandwidth associated with it within the network, and having the policies follow it within that data center is important. But, organizations are starting to move to the world of trying to create an active data center. And if we think about it and we start to move one VM to another location, and we have to have users, connecting in, the reality is that traffic's got to cross over a smaller part of the network, a network that actually has a smaller bandwidth associated with it. And within that virtual machine has to be able to go back and talk to the other side, that database. Particularly in an active scenario, you're not moving everything, because you want to optimize that infrastructure. So you don't want to move everything just to optimize one part of the infrastructure, and then you leave a hole in another part. So you start to see the complexity associated with the traffic patterns going on from just moving it from one data center to another. We start to have this crossover, and we start to over leverage links that are shifted. Now, this is a simple app. Think about multi-tiered apps sharing that WAN link. We really have to understand the traffic, cross that link, the close locations of VM, and data, ensure that we don't cross or create a roadblock within that MPLS or that WAN link going from connecting one data center to another. And that's not even the worst situation. I talked about, the fact is that, creating a hybrid cloud. The adoption of software as a service, right now it's about 40% of the organizations. But infrastructure and platforms are still on the low end. However, organizations are looking to leverage them and be part of their data centers, and not in a sense of just creating an application and sticking it out there, but the reality is really, taking a public platform and their private platforms and tying them together seamlessly, creating this kind of hybrid environment. And so we think about the realities of trying to do something like that, and we look at it. On the left-hand side is my representation of an enterprise data center, where business applications can have their own server, their own storage array, and network segments. We design large applications with lots of features and functions within that single executable. Because the reality is those traditional application designs, is easily maintained and protected, with relatively few application elements. In the cloud, there's a penalty for thinking about this. There's large instances actually typically cost more. The instances are far more common in cloud platforms to take down large applications in total. And the reason I bring this up is because we have to think about how cloud platforms are actually built. Vendors don't buy the same types of servers that enterprises purchase. A typical cloud server has no redundant components, no hot swap power supplies or drives, no redundant NIC cards with failover software. You won't find components for self-healing, motherboard monitoring, or even expansion thoughts. And when we think about that, when a component fails, the cloud provider lets the whole server fail. There's no one rushing into the data center to swap out components. And so then it's predicated on the person who has the application, the customer who has the application on that server, to really move it somewhere else or keep an eye on it and make sure that that application in some ways is set up in a redundant mode. And so what we're starting to see is that application developers are recognizing this and recognizing the fact that they can't create these kind of monolithic types of executable files and in applications, that in this new cloud environment, in this type of platforms, they're really going to have to break these applications down into smaller bytes in pieces and spread them over the platform themselves, so that in case one piece does go down, another piece can come up, or the fact is they can create redundant sections within this application, so you have a failure that the application as a whole does not take a hit in itself. And so you start to think about it, we've complained in the industry as network, and everybody banters around east-west traffic within a data center. Take a look at the fact is that we start breaking applications down into smaller bits, and we move them not just within our data center, but we start to spread them across multiple types of platforms. We're no longer, worrying about 10 gig links and saturating with east and west traffic. We're now crossing WAN links that are not 10 gig links in many ways, unless you're buying some expensive connections to a lot of these cloud platforms. So, that just taking that into account, then we think about users, attaching to them. So where these little pieces are at, and having users not specifically go back to data center and then be, connected out to the cloud. We want the users to overcome that latency and be connected to their closest resource themselves. And so when users are bringing their own devices and their own applications, you got to have this network understand and identify that, as well as identify what's internal and what's external being used by that user. And not the fact that they're bringing in Gmail or they're bringing in, YouTube like everybody likes to talk about. But the reality is they're bringing in their own business applications. SurveyMonkey, Dropbox. The reality is those are being used in the business itself, for people to get their jobs done. And so we have to have an infrastructure not only understand that we're going to create applications on infrastructure as a service or a platform that people are going to use outside resources to get things done. And you're going to have this network, fundamentally connect the user to the best location. And it may not be directing all the way back across the MPLS link. It might be just shifting straight out to the internet and have a sophisticated system be able to do that. So let me explain this in a different way, in a more visual manner. And the reality is companies are starting to tackle this. And most of you will start to be doing this pretty soon. But basically, we come from a world where we funnel everything back to a single location, as you see on our screens, typically across the MPLS network. Everything gets centralized around one DC. But as I mentioned earlier, the idea is to really start to, leverage these platforms. So, one of the things about be able to centralize everything, you start to use WAN optimization to optimize the user experience. Because as we start to create a data center to data center, active type of data center itself, is that, we have within there that the applications are going from one to another. So then you need a global load balancer to shift people from one spot to another and be able to globally load balance the locations. But then, as I talked about earlier, we have users, or we have the infrastructure wanting to use an outside resource, basically, Amazon or a Rackspace out there. So we move some of the application out there. Well, since we have a active data center, the reality is that the active data center needs to have its own internet connection as well. We don't typically just have one. Well, now we need a firewall associated with it. But the other thing is, now that you have these applications in different spots, you're going to want to optimize the traffic between them. So now you have to stick a WAN optimizer theoretically out there. Now, you don't know if that your company may or may not have a virtual instance of it, so you might have to buy one from another vendor, or you might be required to buy one from that vendor itself. But it doesn't end there. The fact is that now you start to have these applications sitting out in the cloud. You want your users to have the best experience. There's no sense of shoving them back across the MPLS link and then back to the internet. What we're starting to see already is organizations doing a right hand right out from the branch office to that location to overcome latency. Well, if you're going to do that, then it makes sense of, well, your global load balancer can't be in the data center. It's got to be closer to the user to understand where the application, where that data is specifically. You got to globally load balance them to the closest location, and now you're shifting the resources closer to that user. Well, now you have internet connection. You better start throwing some more security devices closer out to the user since you're not centralizing the traffic. And it makes sense to now load balance across MPLS and straight internet with, VPN internet as well, if you're going to do something like that to get the best thing with your clients. or with your customers. But it doesn't end there. No sense of sending internet traffic that you don't want to pay for straight out, through your MPLS. You might as well just dump it straight to internet if people are doing Facebook or YouTube or social things that you consider. And so you can see from the screen itself, in the world today is all the discussions about this meshing of this technology and creating this mesh of links within the data center, and people are talking about Trill and spanning tree. The reality is that world we see within a data center is occurring outside the data center, or we're heading that direction as well. And the fact is that typically our layer 4 to 7 services on top of our layer 2 to layer 3 services all within the data center now really have to be dispersed everywhere. That we have to have, firewalls and load balancers and WAN optimizers really attached to every single point out there, whether it's users or databases or data centers or in the cloud platforms, all meshing together and creating this really integrated layer 2 through layer 7 set of services to connect people and give the business the best set of experiences around the application itself. And so we think about this reality of links going up and down and these services being ignited on the fly and being taken down. We have to realize that in this new world that we're approaching, it can't be done by CLI. It can't be done by a network administrator changing things when someone brings in a new device and they're making a connection straight out to the internet and something needs to happen. It's just not cost effective. The speed is what the organization wants. And so we see this rise towards software-defined networking or automation, you name it, orchestration of services itself. I mean, this is what has been pushing the industry this direction. But here's the reality of all this thing that these types of technologies that companies are starting to bring out and talk about, from your layer 2 to layer 3 vendors out there to your 4 to 7 vendors out there. It's predicated on the fact that most of everybody's focusing in on the automation orchestration piece, the controller, or they might be focusing in on the infrastructure piece. Whether they're talking about their, load balancer, they're talking about their switch. But sadly, the piece that's got to make all this happen, all this automation that we are driving towards, or that these technologies that are coming out trying to make happen, has to be built on a sensor. So let me take a step back. Automation is really built on 3 parts. You have the controller, or the automation piece. You have the infrastructure. And the reality is, in a closed-loop system, you have the sensor. Fly-by-wire airplanes. You talk about what goes on manufacturing lines. Anything out there where you want something to take over, the reality is, yes, you have the software, you have the infrastructure, but you have to have something monitoring to create a baseline so you know what the state of the system is, and you can make adjustments accordingly. And so the critical leg to the future of software-defined networking, or however you want to define, that aspect that's coming along, or even software-defined data centers, software-defined infrastructures, where we want to head this infrastructure to, of creating, being able to automatically change and redirect flows and services to the right, for the business itself, to the right person, is got to be dependent on having this monitoring system. And it can't be just monitoring one link or things. If you're redirecting flows across different ports at any time, or different switches, or redirecting them in different directions, everything's got to be monitored and looked at. And so this is why, when people are starting to talk about the direction they want to go, we talk about and we make a recommendation around, you got to get ahead of this curve. A lot of this technology that we want to implement really has to have this monitoring piece. A lot of that's not going to be mature for a while. But there's a great opportunity to start to lay this out and get ahead of what this technology is going to enable organizations are going to do. And so, we start off and say, hey, align your network strategy, your SDN strategy with your monitoring strategy. It's got to be a 1-for-1. For $1 spent, you got to really spend $1 on the other side, because the reality is, to make a lot of that happen, you got to be able to be monitoring every piece of it. Which leads me into that your intelligent network that you're trying to design for, it's got to be, and it's dependent, it's predicated on the fact it's got to be as good as your visibility platform. It's the weakest link in your chain. And if you don't have good visibility across all your switches in your virtual environments, your virtual switches, or your virtual load balancers, or your IDS/IPS systems, if you're not gathering data everywhere and being able to understand what is going on at any point in time, and not for you, but be able to have that feed into a system, there's no way the system can make changes to that underlying infrastructure. And to really do that, you need to start off by monitoring really the tools you have, what you've tapped out there, what links you've tapped, what ports you've got spanned, and then you can kind of move on. Because a lot of times I find organizations, don't even have a clue that realize that, we've had a changeover of operations and personnel, that they do have a lot of taps already, links already tapped, or the ports have been spanned, and they don't realize from a security perspective that exists. But the other thing is that monitoring tools themselves, they have way too many, and there are a lot of redundancy built into a lot of the tools. But here's the kicker to it all. You can actually have other organizations pay for this investment. Don't think from a network perspective it's a networking issue. This monitoring stuff is going to be feeding into application performance management software. The voice team wants to hear about it. The reality is the business, in many ways, is going to be wanting data from the infrastructure itself. And so go off and sell this to them and the other teams and get them to, to pay for this investment, because it's not going to be inexpensive, but it's going to be well worth it. And the reality is that whatever information you have in this network can easily feed all the other infrastructure and operation teams within your organizations itself. Trust me, if you start to head down this direction, you start to build out that area, you'll give me a phone call thanking me for this. Before I hand this over to Shahzad, I want to be able to, kind of ask you, what is your biggest driver for monitoring and visibility? And hopefully on your screen you're seeing an area where you can click on, is it security? Is it application performance? Is it end user customer experience? Are you getting calls about, poor performance in a certain area? Or is it the fact is just overall network performance? You're starting to hear other infrastructure operations team talk about that they're not able to do something, they're not able to do backups because of the network performance itself. And I expect everybody on the call to be, in this webinar, to be answering this, because we have your name, we know who you are. It's just like school. You didn't think you're anonymous, but we'd love for you to participate. And the other person who needs to participate in this as well is Shahzad, and so let me bring him into the conversation. Because I want to, he came from a layer 2, layer 3 hardware vendor, and I just want to kind of ask you, Shahzad, in the old days before you came to Gigamon, what were some of the things you were hearing from customers?
Yeah, thank you, Andre, and it's a pleasure being here on this webinar. While folks are taking a few minutes to answer the poll question, absolutely, let me take a few seconds and answer that question. What we're seeing is a transition. In the past, the primary focus of monitoring used to be on the security side, and that's definitely a big piece of it today. But there seems to be a transition where more and more people are now also, in addition to the security side of things, are gravitating towards application performance management and end-user customer experience management as well. And so that seems to be a transition. It seems to be a direction that the industry is going in. But certainly would love to hear from our users on the call and see how they see the transition as well. Jules, do you have the results from the poll?
Hi, Shahzad. Yes, we do. And they've actually been changing quite a bit since our viewers have been starting to answer. Right now, the majority, with a 37%, have responded A, security, followed by end-user customer experience with 25%, then closely followed by network performance, and finally application performance.
That's really good data. Thanks for providing that. And that actually makes sense, right? Because we do see different environments having a different focus and thrust, but by and large, these areas of customer experience and network performance management are beginning to gain more and more traction as well.
Yeah, actually, I'm surprised by it. I mean, security comes up a lot, but when clients are calling me, this is Andre, by the way, and if clients are calling me, I get a lot's been done, a lot of questions around application performance, just because that industry just shot off, and now applications are a direct revenue generator or affect the business directly. And you think about it from almost any business out there, whether healthcare, retail, manufacturing, so dependent on their technology and particular applications, and so there's a lot of focus in that area. And we get a lot of customers who call and want to know how they can improve the network, specifically the application, and what monitoring tools they can use for the network. So that's interesting. As the security thing came up as number one.
Yeah, absolutely. Well, it's good to have that information coming directly from the users. So, Andre, thank you very much for some very enlightening discussion and some thoughts around there. Certainly, the complexity that we're experiencing today, not just from a network perspective, but even from an application delivery perspective, is growing by leaps and bounds, and the need for visibility and monitoring is only growing linearly with that as well. So I'll quickly jump into my portion. I'll talk a little bit about what Gigamon does, the visibility fabric approach that Gigamon has pioneered. But I won't spend too much time on that. We've actually covered that topic in a fair amount of detail in a previous webinar. And for readers who are interested or viewers who are interested in having a detailed perspective on that, I would encourage you to go to our website, www.gigamon.com, and look at the previous webinar on that subject. But I will quickly introduce the concept here and then do a double click and a slightly more detailed, deeper dive on some of the concepts behind that as well. So just some forward-looking statements over here to put the disclaimer up. Now, the traditional approach to visibility has been to really take your tools, whether the tools for security, for application performance, network performance management, and directly hone them into the production network at different points wherever you need visibility. And the challenge is, as your network scales, both in terms of the complexity as well as in terms of the size, what you need to do is you need to keep adding tools if you need visibility into those pieces of your network. And so this leads to, number one, tool proliferation, but more importantly, this paradigm leads to one where tools have very limited visibility. They have visibility only to those portions of the network that they're connected into. And as you think about a network infrastructure refresh, right, you move from, let's say, 1 gig to 10 gig, 10 gig to 40 gig, and in the future 100 gig, it's a little bit challenging for the tools because now what do you do with the tools that don't have 10 gig, 40 gig, 100 gig interfaces? So the approach has had limited scalability, and that has led to this visibility fabric solution that Gigamon has pioneered, where instead of connecting the tools directly into the network, the visibility fabric connects into production network at all speeds and all the locations that are relevant, 1 gig, 10 gig, 40 gig, 100 gig. And the data from the production network is delivered through the visibility fabric to the tools. Now, this is a paradigm shift because in this approach, the tools are now actually getting data from all pieces of the network, not just where they were originally honed into. In effect, you've centralized the tools and you've made the visibility fabric be the solution that delivers traffic from all over the network to your tools. So it's a far more scalable approach because you can upgrade your network infrastructure. You can change your network infrastructure without having to keep reconnecting the tools into your infrastructure as well. It also addresses another key challenge, which is, as you have different departments, as you have security, application performance management, network performance management, all of these departments require access to the same data. You can simply hang those tools off the visibility fabric, and the visibility fabric can deliver the data to the tools. Now, a key element of this is technology that Gigamon has pioneered called flow mapping. And what flow mapping does is it takes traffic from all these pieces of the network and delivers only what is relevant to the specific tools. This is a fundamental piece of the technology that Gigamon has brought to market, and we'll double click in the next slides on what this means. But as we think about delivering the data to the tools, there are a set of packet transformation and optimization functions that the visibility fabric can do, once again, to optimize the tools. So as an example, if you're monitoring storage traffic in the data center as an example, right, and you're running converged Ethernet infrastructure, we all know that storage performance is significantly optimized by larger frame sizes. And so if you're running jumbo frames, for example, in a network, and you have tools over there, and the tools really don't need 9,000 byte frames. All they're looking at is header information. There is absolutely no reason to send 9,000 byte frames to the tools when all they need is 128 bytes or 256 bytes. And so as the traffic traverses through the visibility fabric can slice the traffic and only deliver what content is relevant to the tools. And now the tools are significantly offloaded and they can perform at their full efficacy as well. So there's a variety of other functions. Deduplication is another one. For example, if you're tapped into your access, aggregation, and core, you may land up seeing 3 copies of the same packet. And a tool may not need 3 copies of the same packet. In fact, if you deliver 3 copies to the tools, you may be oversubscribing the tools three times. And so you can actually do deduplication within the visibility fabric and deliver that traffic, only 1 copy of the traffic to the tools. So this is the heart of the technology that Gigamon has pioneered. Now, let's double click a little bit into this notion of flow mapping, because there's a lot of buzzwords out there when it comes to monitoring networks of the visibility fabric. People talk about things like tap and aggregation. They talk about things like matrix switching. And those are very different. So I'll quickly walk you through what those really mean. This is a very simple slide that talks about matrix switching for the purposes of visibility. And in matrix switching, it's really port-to-port filtering, right? You take traffic on a port, you apply a certain set of filter conditions. For example, traffic is coming in on port 4. You've got packets A, B, and C coming in on port 4. And what you're saying is, I want only B and C to go to tool 2. And that's what happens. But it really is port-to-port. And so this doesn't really solve the problem of delivering traffic from all over the network to the tool. It's really traffic coming in from one location that's going to one tool. And so that really doesn't quite cut the needs. So the next stage of the evolution is what people used to call tap and aggregation. And really, tap and aggregation is really so, I guess, 2008, right? It's, again, old technology. And a lot of people today are talking about, hey, can I use Ethernet switches for doing this kind of function? What you get is this model in with tap and aggregation, where if you have traffic coming in on a port, let's say, once again, you have A, B, C, and D coming in on port 4, and you say, I want to filter A and C, meaning drop A and C. And then you can send traffic, the remaining traffic B and D, to your 3 tools on ports 1, 2, and 3. But that's what all the tools get. You don't have the flexibility of saying, I want A to go to tool 1, B and C to tool 2, and C and D to tool 3. Right? It's a very coarse form of aggregation and filtering, and it really doesn't deliver the traffic to the tools really need. Right? It's delivering a much more coarse set of traffic. And so again, this is pretty old technology. The industry has moved on. What's really the requirement today is this notion of flow mapping. And so again, in the same contextual model, if you have traffic coming in on port 4 and 4 streams of traffic, A, B, and C, and D, you can specify using flow mapping that I want B and D to go to tool 1, a completely different set of conditions. I want A and C to go to tool 2, and I want all the traffic to go to tool 3. Now, if you look at tool 1, 2, and 3, you can see that traffic B and D is actually replicated on port 1 and on port 3. A and C is replicated on port 2 and port 3, right? And so this notion of flow mapping means that individual pieces of the traffic can get replicated, can get filtered out, and that traffic can be customized for the specific tool that you have deployed. So for example, if you have a voice over IP tool measuring voice quality, there is no reason to send Facebook traffic to that tool, right? So you can specify a different condition for that. If you have a traffic tool that's looking at video traffic and you don't want voice traffic to go, you can specify that condition. And you can do this for traffic coming in from a single port or from a combination of ports. Right? It's an extremely flexible technology. Now, the next phase of this evolution is flow mapping with packet optimization. Right? We talked a little bit about this. Right? As you do your flow mapping, and as you say, I want these streams of traffic to go to these tools, along the way, you can actually do packet optimization. We talked about packet slicing as one possible option. Packet masking is another option. Let's say a traffic that's going to the tools has sensitive information. So, for example, if you've got social security numbers or you have sensitive customer information, as the traffic traverses the visibility fabric, you can specify which traffic you want certain pieces of the traffic information to get masked. So you can say, I want social security numbers in this location of the packets to get masked, but for only this set of traffic, and the visibility fabric can do that. You can say, I want this particular traffic to get sliced and delivered to my tools, and you can do that. And so it's a very flexible paradigm of flow mapping in conjunction with packet optimization. The next phase of this is really adding traffic intelligence. What we talked about so far really operates at the packet level. Right? So you have packets coming in, you specify the matching conditions, the filter conditions, and say, I want to mask this packet, I want to slice it. You can do things like time stamping on it. It's a packet by packet operation. Traffic intelligence actually takes us to a whole different level. What traffic intelligence does is it actually does correlation, it does session awareness, and based on that, it can actually do filtering and forwarding. Right? So one example over here is we've got a situation where you have traffic coming in on 2 different ports. And what I've specified in this third rule down at the bottom is I want A, B, E, and F to go to tool 3. Now, if you notice, I'm getting packets A and B on port 4, and I'm also getting it on port 5. And so as I take this filter condition and say I want to do some packet slicing, what I get after that operation is 2 copies of A that are sliced, 2 copies of B that are sliced, and E and F. Now, if I simply send this to the tool, once again, even though I've sliced the packet and I'm optimizing the traffic that goes to the tools, I'm still sending duplicate copies to the tools. So you can apply a traffic intelligence function that can actually do deduplication on top of the slicing and then send just a single copy of the packet stream to the tools. Now, this deduplication function is something that has intelligence because it recognizes duplicate packets, it recognizes duplicate flows and streams, and so there's a higher order function that comes in when you apply traffic deduplication on top of flow mapping technology. This direction of traffic intelligence is actually where the industry is going, and to understand that, let's take a quick look at why this is becoming more important in terms of where the network is evolving and where tools are evolving. So clearly today we have this big growth in infrastructure, where infrastructure is moving from 1 gig to 10 gig to 40 gig and 100 gig. Right? We're seeing this in the carrier side. Today there's a big infrastructure refresh happening in the mobile carrier, for example, to 4G LTE. We're seeing this in the enterprise side, where over the last few years people moved from 11A-BG to 11N, and in the future to 11AC. And on the data center side, where people are moving service from 1 gig to 10 gig and the core and aggregation to 40 gig and 100 gig in the future as well. So data is only growing, speeds are only growing, but along with that, you have a tremendous amount of complexity coming in. Server virtualization has created blind spots inside the server. And so when you think about your monitoring infrastructure, you've got to be able to monitor virtual machine communications inside the server, which doesn't even hit the network. You've got network virtualization, which is a big thing these days. This is the technology, for example, that VMware is pushing through NSX through their acquisition of Nicira. Microsoft's pushing NVGRE, IBM's pushing Dove, and these are all overlay technologies. They create virtual overlay networks, and that creates another challenge from a monitoring perspective, because tools don't understand this overlay technology, and so the tools are blind to that traffic, right? And so one of the big requirements we're seeing these days is, as people move towards network virtualization, they want the visibility fabric to be able to address this challenge with overlay networks and to be able to provide data in a format that tools can understand. And then you have SDN, of course, which really has a centralized controller model and a distributed forwarding model. And as we think about the transition to SDN, SDN is going to create new blind spots, right? Because what happens between the controller and the switches is today not monitored, simply because there isn't too much deployment out there. But if that paradigm gains hold, then you will absolutely need to be able to monitor what's going on between the controller and the switches to ensure that your SDN model is operating at its full efficiency and is operating correctly as well. So there's potential for new blind spots to be created over there. And there's NFC, Network Functions Virtualization. This is the buzzword. In fact, I would say SDN is so 2012. 2013 and 14 are all about NFV, Network Functions Virtualization. And what NFV does is that it moves network functions like application delivery controllers, firewalls, load balancers as virtual functions inside the server. And that further creates more blind spots within the server itself. So you have data growing at tremendous volumes. You have more complexity coming in on the network side. And the tools themselves are evolving as well. So what you have is you have security and vulnerability management tools, right, which require a broad access to traffic data to find the one needle in the haystack. And then you have NPM tools, network performance management tools, which also look at a broad section of the data, but they are less concerned about the content in the data. It's all about network information, header information. And so what they need is perhaps a smaller subset of that data. Now, as you think about application performance management, there are tools that are focused on very specific applications. Voice over IP quality measurement. That tool does not care about video, it does not care about Facebook, does not care about Twitter. And so the data that those tools need is very, very limited vis-a-vis the data that's floating around in the network. And if you look at the CEM tools, the customer experience management tools, once again, they're very specific in what they're looking for. Why did this page take long to load? How long did it take for my customer transaction to complete? These tools are again looking for very, very specific information. And so what we have over here is a very interesting trend where there's a tremendous growth in the volume of data, but the percentage of data that is relevant to these new classes of tools is an increasingly shrinking percentage. right? So this is creating a big gap over here. And this gap, where there's huge volumes of data, but the tools really need a smaller percentage of that to really operate at full efficacy, is posing a challenge. And this is where this traffic intelligence function comes in, right? And that's where the visibility fabric is really going. It is to fill that gap that we see becoming more and more of an issue today, 2014 and 2015 as well. And so if you look at where Gigamon is going as a visibility fabric, right, we started with flow mapping technology, which we talked about in a fair amount of detail, right? And that's, again, a completely different technology when you think about matrix switching or tap and aggregation. On top of that, what we've done is we've added the ability to do packet transformation, packet optimization, so you can do packet slicing, you can do packet timestamping, you can do packet masking, all to optimize the tools. And now we're adding traffic intelligence on top of that, right? So we can do correlation, and based on that correlation, we can be more specific in what traffic gets forwarded to the tools. So this is how you think about the evolution of the visibility infrastructure, of the visibility fabric. And the way we are bringing this to market is through a four-tier architecture. The first one consists of a set of visibility fabric nodes, and these really provide pervasive visibility. This is critical. Again, Andre had mentioned the need to be able to monitor your entire infrastructure. So for example, if you have a highly virtualized infrastructure, we have a GigaView VM product that can look inside the server, that sits on the hypervisor, and can do filtering inside the server, and that can do slicing inside the server, and only deliver just the relevant content to the tools. This is important so that you don't overload your production network when you're transferring the data to the tools. We have the GigaView HB1, which sits in remote branch locations. And again, when it's sitting in those remote locations, it can do flow mapping, it can do slicing, it can do deduplication, so that whatever data you're transferring from those remote locations to your centralized tools does not consume valuable bandwidth as well. So you need all these visibility fabric nodes to provide pervasive visibility. And then tie those together with a nice GUI-based platform, a point-and-click, drag-and-drop operation for saying, I want traffic from this node to go to that tool. Don't have to deal with CLI. It's a very intuitive GUI-driven platform, which really simplifies the way you manage your infrastructure for monitoring. And then building out a set of APIs so that people can write some interesting applications on top of them. And we've got a couple of interesting applications that we've talked about. These visibility applications do more than just packet operations. They do correlation, they do flow-based correlation, they do user-subscriber-based correlation. Deduplication is one application that we've released, very successful because it significantly reduces the load on the tools infrastructure. Another one that we've talked about is called FlowView. FlowView is very interesting. Today, many people use technologies like NetFlow for sampling. And these technologies do random sampling. And the challenge with random sampling is that it is random. And so you can potentially have valuable customer data get dropped because of the randomness in the sample. And so what technologies like FlowView and what visibility applications like FlowView do is that they take a sample of the subscriber set. So let's say you've got 1 million subscribers or 10,000 subscribers. We take a sample of that, let's say 100,000 out of 1 million. And for those subscribers, every packet gets sent to the tools. It's very deterministic. So if you're doing customer experience management or subscriber management, your tools have full visibility into that particular subscriber subset and their traffic patterns. Right, so that's another example of some stateful correlation that is being driven to optimize the tool infrastructure. And so when you look at this big picture, when you think about your monitoring infrastructure, your visibility infrastructure, it's important to make sure that you have pervasive visibility, physical, virtual, cloud, remote locations. You have a nice intuitive GUI-based solution to go be able to manage that infrastructure, and that you have a set of traffic intelligence applications that can do things like deduplication and deterministic traffic sampling that optimize your tools significantly. And so this is really the direction that Gigamon is heading. We're very excited about this, and we think that there's a lot of value that this can bring to the monitoring infrastructure. That brings us to our second poll question. This is interesting, actually. The question here is what and where are your greatest blind spots when it comes to visibility and monitoring? Is it in the remote locations? B, is it in your virtualized applications? Or C, are you really concerned about blind spots due to encrypted data and transactions? They're all very different areas where people have experienced blind spots. Would love to get your feedback. Once again, you can poll using the same approach that we did for the earlier question. And while users are polling on this, Andre, I'd like to perhaps bring you in and get your thoughts. As customers talk to you, do you have a sense as to the direction that customers have the maximum pain point?
Well, yeah, I get a lot of my calls. I would say at this point right now are in two areas. One is data center, virtual, the VM's moving, and everybody just says, it's cloudy, or they just can't see anything, and especially in that virtualized environment. And the other one is across the WAN links, because now it's becoming, there's just so much happening in that environment, and so those are probably the two areas that I do get the most calls on at this point. Well, I don't know. Now you bring it up, I'm going to throw a third one into it. Wireless, right? And as people move that as a primary way to connect, a lot of organizations haven't deployed probably a robust wireless solution, and so they're getting a lot of complaints from their users on that side. So they need to have some things done over there. So
yeah, that's
I take that back.
Right? And a lot of the wireless communications are encrypted as well. And so it's going to be interesting. Let's see what the users had on this poll. Jules, do we have the answers from the poll?
Yeah, it seems like the majority of people have responded with a 42% encrypted data and transactions, followed with 37% virtualized applications, and finally 21% of our viewers responded remote locations.
That's very interesting. Thank you, Jules, for that. Andre, this is interesting, right? What are your thoughts on that?
Yeah, it is. I'm surprised a little bit by it, but it makes sense that we get that respondents within those areas.
Yeah, I think it. Now that I think about it, it does make sense, because a lot of transactions today, especially a transaction-oriented environment, right? Everything is SSL encrypted, as an example, and so one can certainly see that as being a big challenge when it comes to the whole monitoring and visibility infrastructure. That's great. That's great information to have. I think that brings us to the end of this section of the presentation. I'd like to say thanks to the audience, and what we will do now is we will open it up to Q&A from the audience. So let's see if we have some questions online, Jules.
Yes, we've actually have received quite a few questions during the presentation, so let me go ahead and begin to pose those for you. Let's see, we have a question from Ryan. Can I apply traffic intelligence to remote sites, or in other words, how does this help me get better visibility into remote locations?
Yeah, that's actually a great question. We see this come up a lot on our end as well. What's happening out there is that a lot of people have, for example, in retail, there are multiple branches. Banking, you've got multiple branches. Even on the data center side, you've got backup disaster recovery data centers. And the challenge people are experiencing is that they don't want to replicate the tool infrastructure in all these multiple locations. They don't have tools, or it's cost prohibitive to go put tools in all these remote locations. And so what they want to do is they want to have the ability to troubleshoot and monitor all these remote locations and then drive a subset of the traffic back to the centralized tools so that somebody at the headquarters or in the NOC can actually manage and troubleshoot the information. So this is a challenge, and to address this challenge, one of the products we have introduced recently is something called the HB1. We talked about it very briefly. The HB1 is a platform designed specifically to sit in remote locations and branch offices, and it does offer the full flow mapping capability, so you can do all the kinds of filtering that you need in these remote locations. You can also apply all the packet optimizations like packet slicing at the remote location, and then on top of that you can apply this traffic intelligence and do things like deduplication. And after you've done all this, you can only send the relevant deduped and optimized data streams to your tools which are centralized. And so the HB1 is explicitly designed for that purpose, to make sure that the burden on your WAN links and when sending data back from these remote locations is not a significant burden. So that's a great question. Andre, anything you'd like to add to that?
No, I don't. Nothing on particularly on that subject.
Great. And anything else, Jules? Any other questions?
Yes, we do. We have quite a few. Following question, let's see. Emma asks, how do I get visibility into VMs that are moving? Is there a way to avoid blind spots with VMs in motion?
That's a good question as well. Before I jump into the answer, Andre, is this? I'll quickly turn it to Andre, and then I'll provide some insight into what Gigamon's doing as well. But Andre, do you see this come up a lot as well in terms of dealing with VM mobility and visibility there?
Oh yeah. I mean, like I said earlier, well, I originally started off with two issues being coming up the most, but then I went to three. Yeah, VMs moving and knowing that the process has started, it's ended, what it means for the traffic itself, and if the VMs are in that layer 2 environment where they're being used, and yet they're being moved, and so you want to make sure you have connectivity and it's responding to the users and stuff. And so a lot of that, the issues surrounding that, and really having that visibility is what we get a lot of calls on from customers and the issues around it. And so it comes up on this is exactly where they say you don't have that visibility in that virtual environment when you're shifting things around.
Got it, yeah. And so, from a Gigamon perspective, we actually recently introduced a new capability in our GigaView VM solution. As I mentioned earlier, we have a GigaView VM node that sits on a hypervisor inside the server, and it can monitor conversations between virtual machines, and then you can apply flow mapping, filtering, slicing to send relevant traffic back to your tools for the traffic that's inside the server itself, VM-to-VM communications. However, a capability we've added very recently over there is to do exactly what this user has asked, right? Which is if VMs are moving, to be able to move the monitoring policies to track those VMs, right? Which is very powerful because as your virtualized infrastructure becomes more dynamic, as VMs are moving from server to server within a rack or across racks or across data centers, it becomes pretty important to make sure that if there are applications that you are tracking from a monitoring perspective, that you don't lose visibility into that. So some recent announcements we've introduced actually have the capability to move your monitoring policy to track the VM so that as you have a virtual machine mobility, you don't lose that visibility in that dynamic environment. So that's a great question, and it's something that we've recently introduced, and we're very pleased to see that there seems to be interest out there in this. I guess we have time for one more question. Jules, can we pick another question?
Sure, let's do one final one. There's a question from George, and he asked, can you talk a little bit about how I can address SDN with what you do? Okay,
I'll take this one. This is interesting. I guess we can spend a lot of time talking about SDN itself because it's a pretty big topic. But very quickly, I'll touch upon two key aspects. One of the key areas that people are talking about SDN being applied today, and I would love to hear Andre's thoughts as well on this, is this notion of network virtualization. Right? If you look at things that VMware, for example, has announced recently around NSX and their acquisition of Nicira, it's squarely targeted around network virtualization. And one of the challenges that we talked about when it comes to SDN, specifically with the application being network virtualization, is that tools today don't understand that traffic because all the technologies that are used for network virtualization use some kind of overlay or encapsulation. So, for example, there's VXLAN from VMware, there's NVGRE from Microsoft, there's Dove from IBM, right? And all of these have tunnels, which in many cases are initiated and are terminated inside the hypervisor, and the tools really don't understand the tunnel formats or anything. And so we have introduced capabilities to be able to effectively strip the tunnel headers before forwarding the tools to the traffic to the packet. And in the future, we'll be looking at solutions where you can do filtering based on outer tunnel headers, inner tunnel information, and make that very flexible so that the tools can be optimized as well. So there's a lot we're doing for an SDN environment from a network virtualization perspective. But Andre, do you have any thoughts on this whole subject of SDN?
Yeah, there's one exactly addressing that part of it. I also want to address the parts of just SDN, no matter how, so overlay or physical. I want to address the programmable part. But, a lot of things that people are trying to strive for, moving that VM or really optimizing those infrastructures, is dependent on getting information. And so, having the visibility into, switches, that not having the network respond to a change, but letting the system know that it's ready to go. And so what I mean by that, so there's no sense of moving a VM from one location to the other just because you have available CPU on that server, when maybe in one of the links, one of the connections, it's already been saturated by a lot of traffic actually going to another server. And even though, because it's, that link itself is hosting multiple servers upstream, it's upstream link itself, that important information should be feeding into other tools, and those are part of this whole concept of software-defined data centers, or even what software-defined networking is trying to do. It's not the reactionary piece, but it's taking information so that you can make proactive choices and redirect flows. And so, this SDN world is going to be predicated on gathering information before changes are made. And so this is why, something harping on this at the beginning. And you bring up a great point with overlays is, if we're tunneling through everything, you got to make sure that the traffic that's going through, so you can make the right decisions on it. So it's important to have that monitoring capability in that encrypted world. So I can't get more vocal or more excited about it, but it's a passion of mine to talk about how it's related to SDN.
That's a great point, Andre. I guess in effect what you're saying is that as we start thinking about the evolution to SDN, we need to start thinking about being proactive with the monitoring infrastructure and not reactive, right? Which means you got to design your monitoring infrastructure in and architect it in.
Yeah, and the beautiful thing is you can do it. This is something actually you can do today. It's mature monitoring, and that fabric out there, the monitoring fabrics are mature technologies today. Unlike the reality is a lot of the SDN isn't, but that's good. It's actually perfect, because you want to get that out there first before you start laying this other thing, because otherwise you start deploying SDN technologies, it's not going to be any better because you don't have that visibility to that area to make changes. So spend the time now as that technology matures and invest on the monitoring side, and you'll get a lot more rewards when you start implementing that SDN technology.
Fantastic. That's great insight. I think we're out of time. I think there's several other questions, but unfortunately we're running out of time, so we'll take the time and perhaps answer them separately. I'd like to say thank you to Andre for taking the time and providing some valuable insights over here. Appreciate all the users joining the call over here. I hope this webinar has been useful and informative for everybody, and stay tuned for the next one.
Thank you, Shahzad, and thank you, Andre. It looks like that about does it for the presentation today. Thank you, everyone, for attending. And just a reminder, if any of your questions were not answered today, or if you have any additional ones, make sure to use that calendaring feature on your screen to schedule a follow-up conversation with your local Gigamon solutions provider. Also, a link with the recording of today's webinar will be sent to your email shortly. Thanks again to Andre Kindness and Shahzad Merchant for your time today. Have a great day, everyone.